everyone. I am Supreet Dey and I have taken part in the Emertxe online internship in the embedded system domain, and I am presenting my project which goes by the name microwave oven simulation, and I am presenting it on MPlab IDE. So these are the topics we've covered during the course of the internship, which includes starting from C, its introduction, then we went for the conditionals, loops and operators, then arrays and pointers, functions and storage classes. Next, the topic begins for the embedded systems and microcontrollers, in which we explored the MPlab IDE, the MPlab and the XCD. Then we got introduced to various peripherals like the PIC 16F877A. We have given multiple quizzes and we have finally attended the Disha workshop. So these are the contents of the presentation. First I'll be introducing what a microwave oven is, then we'll go on to the requirements, then we'll explore the microcontrollers and processors, then we'll explore MPlab. It will be covering CLCD, then it will be covering the matrix keypad, the interrupt service routine, timer, and at the last we'll be having a project implementation demo. So what is a microwave oven? A microwave oven is used to heat the food using microwaves, which is of the form of electromagnetic waves. Means we are using EM waves to preheat the food or heat the container on which food is kept using the radiation heat radiating from the waves. There are several modes in a microwave oven, and in this project we are going to implement 4 of them. They are as follows: the micro mode, the grill mode, the convection mode and the start mode. Firstly, the micro mode. This mode is to cook food in a traditional way. The maximum power used in this is 900 watts and the maximum time through which the food gets cooked is 60 minutes. The grill mode. This mode is used to cook meat and bread, means the food which require more heat capacity are cooked in this mode. It works as the micro mode, but the purpose is to cook meat and bread. The convection mode. In this mode, user can set the oven to preheat for a particular temperature. Usually it takes 3 to 5 minutes to preheat the oven. After heating is done, the timer can be set as per the requirements. The requirements of this project are the MPlab IDE, the XCD compiler and the MPlab. The PIC 16F877A, a 16:4 LCD, the tactile switch, a matrix keypad and a timer of mode 2. So what are microcontrollers and microprocessor? An integrated circuit which is capable of being programmed to perform a specific task. It has a design restriction such as memory size, input-output capabilities, peripheral functions, etc. Microcontrollers can be chosen on the basis of its application. Different places require different types of microcontrollers to operate. Like for traffic control, there would be different microcontrollers. For controlling a robot, there would be different microcontrollers, and so on. MKB, the matrix keypad. This is used when more number of user inputs are required and we still want to save some volt output lines. These keypads are commonly used in calculators, digital lockers, telephones, our keypads, and anywhere tapping is required. Microcontroller versus microprocessor. In a microcontroller, all components will be in a single chip. It is less flexible and its design complexity is less as compared to the microprocessor. In a microprocessor, all components are assembled separately. More flexible it is and more the design, the complexity. On the right side, we can see a picture which contains a microprocessor and microcontroller. In the microprocessor, there is a control unit, an arithmetic logic unit, CPU, and some registers. This is more flexible and the design complexity is more because every component has a separate unit. Next, the microcontrollers. All components can be seen in a single chip: the CPU, the input-output ports, counters, timers, RAM, and ROM. Therefore, it is less flexible, but the complexity of the design is less. We can see the MPlab architecture here, which contains a GPIO, general purpose input-output, the I2C RTC EEPROM, a temperature sensor, an analog to digital converter, LEDs, RS232, buzzer, digital keypad, SSDs, matrix keypad, and an LCD to operate the whole function. About the PIC 16F877A. Next, we'll talk about the CLCD, character liquid crystal display. In PIC SimLab, there are two types of display, a 16:2 display and a 16:4 display. This is mentioning the dimensions of the display. It displays the ASCII characters and some special characters, and it operates in two types of communication modes, 4-bit mode and an 8-bit mode. Next, on to interrupts. What are interrupts? An interrupt is a communication process set up in a microprocessor or a microcontroller. An internal or external device requires the microprocessor unit or microcontroller unit to stop the processing. Like, it will interrupt the flow of program and run the program which was in the interrupt vector table. Then the MPU or MCU acknowledges the request and attends to the request. It goes back to processing where the interrupt had interrupted the flow of the program. Interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. It attends to a request of an interrupting source by clearing the interrupt flag and should have register contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed and it disables global interrupt enable. Place the address from the program counter on the stack. Timers. Timers are important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time and generating delay, etc. Timer/counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, is of 8 or 16 bit. Tie is referred as the change from one number to the another number, and it may be a up counter or a down counter. Quantum, which depends on the system clock setting, is a measure of time responsible for the tick. And then pre-scaler or post-scaler may be the scaling factor. It may be 1:1 or 1:8, etc. Let's see the output of the project. We'll definitely show that demonstration at the end of the video. So the left side pic is a power on switch, and the right side pic shows the 4 displays, the micro mode, the 4 modes, the micro mode, grill mode, convection mode, and start. In the micro mode, the power is shown to be 900 watts and the timer is of 55 minutes. You can see we can clear using the asterisk symbol, or we can enter using the hash. In the convention mode, you can see that we can set the timer in degrees Celsius, and again the asterisk command for to clear the system, and hash for enter. You can see a fan on the right side which will be turned on as soon as we hit enter, which regulates the temperature of the whole system. You can see the PIC SimLab simulated in this, and this is the whole of the ID. It uses the PIC 16F877A. You can see the relays, you can see the ports, we can see the displays, etc. On the right side, it is a preheat time, and the time remainder is set to be 178 seconds. So now there comes the start mode. We start the timer, and we have seen that 27 seconds have been elapsed. So when we press the 4th option, it will start or resume. If we press the 5th button, it will pause, and 6th for stopping. When the process is done, it's time up, the display will show time up, and the process ends. If we press RB3 key on PIC-SimLab, we get this notification of door on. Like, it will give a warning that the door is open and please close it to avoid any types of accidents or etc. So this, we can see the relays, we can see the switch, and we can see the different types of button. We have discussed what RB3 was. You can see the number pad from 1 to 0 and hash and asterisk, and the display is a 16:4 display. We have discussed about that. There is a serial input, that is RS485. There's a reset button on the right side, and we can see various ports. The registers you can see beneath the PIC-SimLab logo, etc. So this was our presentation. We'll go further for the demo. Thank you. We'll be showing the demo now. So coming to the simulation part, as you can see, I've opened the MPlab IDE, and you can see that I've created some temporary variables. Like for the timing variables, I've created the second, minute, and the flag variable. Now the operation flag variable will be on power on mode. So I've created a function which takes in the crystal display function and the matrix keypad. Now for RC2 as output, I've kept the fan DDR as off for now and fan also as off for the initial conditions. And I have initialized the timer 2. The PI command is set as high, that is 1, and GI command is 1. And initially the buzzer is off. That's it. Now we have declared a key variable which is of unsigned type and a reset flag. While the condition is true, we have set the matrix keypad state to run according to our user input. If the operation flag is matches with the command we have given for out of the 4 modes, it will execute the further code. If key is 1, then we have set the operation flag as micro mode and reset flag as reset mode. Then we have cleared the screen. On operation, as we remember, for the power mode 1, the maximum power output was 900 watt. That's what we have displayed here with a delay of 2000 milliseconds, that is 2 seconds. Then we have cleared the screen. Else, if the key is 2, we will operate in the grill mode, in which the operation flag will be grill mode and reset flag will be set to reset. Similarly, for key 3, we have the convection mode and 4 will be the start. Next, as you can see, that's it. Now we will build the program. We'll click here. We'll build the program. And as you can see, the build is successful here. As you can see, the build is successful here. Now, this is the PIC 16F877A. We'll go to the file and we'll load the hex file here. This is the hex file. We'll load this. As you can see, the 16:4 display is getting started and showing the greetings. There are 4 modes: the micro mode, the grill mode, convention mode, and the start mode. You can see we have a virtual fan here, which controls the temperature. We have serial inputs here. This is a 16:4 display. These are the LED display tabs, and the MKP, the matrix keypad, can be seen here. Now we will select one of the 4 modes. That is, first we'll go for the micro mode, and as you can see, it has started. Power was 900 watt, and it will set the elapsed timer. To clear the readings, we'll press the asterisk. To enter, we'll press the hashtag. As you can see, we have pressed the enter and that time is up, and it will automatically stop the whole system. Now we'll go for the grill mode. We will give at least 50 seconds for this. And as you can see, the 50 seconds timer has started. We can either start, pause, or stop the process. You can see the temperature is 27.5 degrees Celsius. This is the room temperature, and the LCD code is, the clock is operating at a 20 megahertz frequency and speed is normal. Microcontroller, we are using PIC 16F877A microcontroller. It is operating in relay 1. see the time is up. Next we'll go for the grill mode. Now we'll go for the convention mode. As you can see, there are 16 characters in the LCD display, which is of max length, and there are 4 columns. There is a built-in cooler for the fan, and the temperature will be set according to us. And there are 2 relays which we can operate. The reset button resets the microwave. This is the microcontroller which we are using. It is PIC 16F877A. The EEPROM which manages the memory, and it will always be in the run mode. These are the ports which will be working upon, and these are the ports, and we'll be going for the convention. We'll press 3 in the MKP, and we'll set the timer as 50. Then we'll press enter. As you can see, the timer has started and the fan is rotating, which signifies that the temperature is being operated, and we can start, pause or stop according to our wish. This is the room temperature which we are operating on, and as you can see, the microwave will run for the specified number of time. You can see the timer is about to end, and it gives the beep sound, which means the timer has ended. Next, we will go for the 4th mode, that is start. We have set the timer, it is of 30 seconds. It is operated in a simple mode, the default mode in which all microwaves are operated. Seconds is the standard time of operation, and as you can see, the microwave is about to end the task. And one more mode which we are left to display the timing was the micro mode. It shows 900 watt, and the timer would be of 20 seconds. We will start. This is the micro mode has also started with a maximum power of 900 watt. You can see all the 4 modes have been displayed. This was the end of our simulation, and I'd like to thank Emertxe for this opportunity, and that's it. Thank you. Now we'll go for the convention mode. As you can see, there are 16 characters in the LCD display, which is of max length, and there are 4 columns. There is a built-in cooler for the fan, and the temperature will be set according to us. And there are 2 relays which we can operate. The reset button resets the microwave. This is the microcontroller which we are using. It is PIC 16F877A. The EEPROM which manages the memory, and it will always be in the run mode. These are the ports which will be working upon, and these are the ports, and we'll be going for the convention. We'll press 3 in the MKP, and we'll set the timer as 50. Then we'll press enter. As you can see, the timer has started and the fan is rotating, which signifies that the temperature is being operated, and we can start, pause or stop according to our wish. This is the room temperature which we are operating on, and as you can see, the microwave will run for the specified number of time. You can see the timer is about to end, and it gives the beep sound, which means the timer has ended. Next, we will go for the fourth mode, that is start. And we have set the timer, it is of 30 seconds. It is operated in a simple mode, the default mode in which all microwaves are operated. 30 seconds is the standard time of operation, and as you can see, the microwave is about to end the task. And one more mode which we are left to display the timing was the micro mode. It shows 900 watt, and the timer would be of 20 seconds. We will start. This is the micro mode has also started with a maximum power of 900 watt. You can see all the four modes have been displayed. And this was the end of our simulation, and I'd like to thank Emertxe for this opportunity, and that's it. Thank you.